Determine each of the following. For part A, we have the integral of sec squared of negative x dx, and we do have a formula. It's not on the formula sheet, but because we have knowledge of how to differentiate tan and that relates in the sec squared function, we also then would know that integrating sec squared of ax dx is equal to 1 divided by a times tan of ax plus c, where c is a constant of integration. So that means that the integral of sec squared of negative x dx, if we apply the formula, is going to equal 1 divided by the coefficient of x, which is negative 1, multiplied by tan of negative x plus c, and that is simply equal to 1 divided by negative 1 is simply negative tan of negative x plus c. So that is the answer to part A of this example. Now, interestingly, if you had have put that in the calculator, you'd find that that is simply equal to tan of x plus c. And that's because if you reflect the tan graph over the x-axis and the y-axis, then you just get back to the original tan of x graph. So the calculator would just simplify that calculation to tan of x plus c. For part B, we'll apply the same formula so that the integral of 2 sec squared of 3x is going to be 2 times 1 over the a value of 3 multiplied by tan of 3x plus c. And simplifying that, 2 times 1/3 is 2 over 3 times tan of 3x plus c. So that is the answer to part B of this example. So for part C, we're going to integrate 10 sec squared of x plus 9 all divided by 3 dx. And what we're going to do is we're going to apply this same formula. So this is going to equal 10 times 1 divided by a. And in this example, the coefficient of x is actually 1/3. So that's our a value. So we're going to have 10 times 1 divided by 1/3 times tan. And any linear expression that's inside this function, when we integrate, this rule still applies. So as long as the x plus 9 over 3 is linear, which it is, we still just have x plus 9 over 3 inside the tangent function plus c. And then simplifying this, we'd have this is the same as 10 times, and 1 divided by 1/3 is 3. And then we're still going to have tan of x plus 9 over 3 plus c. And then in our final step, we can get 10 times 3 is 30 times tan of x plus 9 divided by 3 plus c. So that is our answer to part C of this example. And finally for D, we have the integral of negative 1 divided by 6 times sec squared of 9x over 4 with respect to x. So following the same formula as we've been doing for the last 3 examples, this is going to be negative 1 over 6, so this constant stays out the front, and that will be multiplied by the reciprocal of a. So the reciprocal of 9 over 4 is simply 4 over 9. So there we've just been efficient with our working. So instead of doing 1 divided by 9 over 4, we know that that's just the same as 4 over 9. And then of course this would be tan of 9x over 4, and then we get the plus c value, which is that constant of integration that we need to add on. So this is equal to negative, and 1 times 4 gives 4 in the numerator, and 6 times 9 gives 54 in the denominator, and that's still going to multiply tan of 9x over 4 plus c. And then in the final step, we can just simplify the negative 4 over 54 to be negative, and we know that that would become 2 over 27 when we cancel the common factor of 2. And then that would still multiply tan of 9x divided by 4 plus c. So that is our final answer for part D of this example.